In this third example, we have the inverse tangent of the square root of 3. Remembering in this case first to determine where tangent is and which quadrants it can be used in. So it is in quadrants 1 and quadrants 4. Now again, because this is positive and quadrant 1 is always positive, we're going to use quadrant 1. Since this is tangent, we have the square root of 3 over 1. So the square root of 3 is going to be our opposite, and 1 will be the adjacent. So now this gives us enough information to actually draw the triangle in quadrant 1. So here's a quadrant 1 triangle, just like so. You get your inner angle, and you have the opposite side as square root of 3. You have your adjacent as 1, and as we know at this point, the hypotenuse is 2 because this is a 30, 60, 90. You do have to determine which one's the 30 and which one's the 60. Remember, opposite of the shortest side, that's your 30. Opposite of the longest side is your 60. So our inner angle here is the 60-degree angle, okay? Which means in this case, the 60-degree angle as a radian is pi over 3. And that is that. If you're at this point watching the videos and you're feeling pretty confident, I would definitely start some. I've got 3 more examples of a couple odd cases that you may see, and I'll do those 3 right now. So here are the next 3 examples. All right, so again, the instructions essentially say the same thing. Find the exact value if it exists, write your answer in radians. This is arc sine. So again, since it's sine, this is quadrant 1 or quadrant 4. Okay. Now again, you see the negative sign, so it can't be quadrant 1. All right, so you already know that your triangle is going to be down here in quadrant 4. Okay. So the other thing, since this is the angle we're looking for, okay, this angle here, that's supposed to be a theta. Sorry, that's a bad drawing. Other thing to remember, this here, okay, is actually 1 over the square root of 2. Okay, remember that this finalized answer is rationalized. So before you build your triangle, you need to reverse the rationalization. Okay, so in this case, a hypotenuse, this is opposite over hypotenuse. We talked about in some of the previous examples, hypotenuse is always positive. Okay, so the hypotenuse here is going to be the square root of 2. The opposite side will be -1, which again in quadrant 4, this side being negative makes sense, and this would be 1. All right, so that is going to make your theta angle a 45-degree angle. Okay, now one thing to keep in mind here, okay, yes, we're going to write our answer in radians, okay, but you need to remember that you're in quadrant 4. Okay, so in order to get from the initial side here to the terminal side here, you're actually going in a negative direction. So your answer is actually negative pi over 4. Remember that when you're in quadrant 4, you're going to be using negative angles because you're going down from the initial side. Okay. Now, the next one's a little interesting because we have the arc cosine or inverse cosine of -2. So in this case, that's -2 over 1. Okay, since it's cosine, this is the adjacent and this is the hypotenuse. Okay, and since it's cosine, this is either quadrant 1 or quadrant 2. And since it's negative, you obviously can't be in quadrant 1. Okay, so a quadrant 2 triangle is gonna look like this. There's your quadrant 2 triangle. There's your inner angle, which you're trying to find. Your adjacent side here, your hypotenuse here. All right, and in order to figure this out, you can kind of, looking at this, it kind of looks like a 30, 60, 90 triangle, but yet the numbers are in the wrong spots. Usually the hypotenuse is supposed to be longer than the adjacent side. That right there is a little bit suspect. Usually in this type of situation, if it's not a special right triangle, you want to try and find the third side just to see where you're at, just making sure that it is a triangle. Now, if we do this kind of turns out interesting. If you make this side B, so we'll call that A, B, and C, you do the Pythagorean theorem. So you do -2 squared, B squared, and 1 squared. This gives you 4 plus B squared equals 1. All right, and if you subtract the 4 from both sides, Okay, you're actually going to get b squared equals negative, whoops, sorry, that's negative 3, which means b is the square root of a negative number. You and I both know that a negative number is imaginary, and we can't have imaginary triangles or imaginary angles. This has no solution, okay? There is no answer here. There is no angle that'll ever make a cosine into a negative 2. It just isn't going to work. All right, so the last one, okay, is arctan of 0. All right, so this one's kind of a bit of an odd situation as well. So inverse tangent has to be quadrant 1 or quadrant 4. Okay, and again, since this is positive, essentially you would really, well, technically 0 is never positive or negative, but with a 0, quadrant 1's the way to go. Okay, it's the easiest. It's where you deal with all the zeros here. And this is essentially 0 over 1. So your hypotenuse is, sorry, not your hypotenuse. All right, because this is opposite, that's adjacent. That's why it's always good to label these. So then you have 0 here on the opposite side, 1 here as the adjacent side. Okay, which kind of makes your hypotenuse a little suspect. Okay, what's interesting about this is with an opposite and adjacent, anytime you have a 0, usually means you're sitting on an axis somewhere. Okay, because again, we're assuming this hypotenuse is 1 since we're in the unit circle. Okay, now if that is the case in the unit circle, this point is the point 1, 0, where this would be kind of your sine value, this would be sort of your cosine value. So as you can see, when you stack sine over cosine, you get 0 over 1, okay? So the angle that creates this, in other words, what you need to think about is how to get to this point. If you start at the origin, this terminal side is where you start, but the terminal side is also where you end. So because you start and end at the same point, that means you actually moved 0 degrees, which in our case is also, whoops, 0 radians. This, since you're actually at the point 1, 0, you actually haven't moved at all. There is no angle. So the angle here is actually represented as 0 radians, which keep in mind, not having an angle is very different than not having an answer at all, okay? 0 radians does truly exist. This is no solution at all, okay? So there are a couple kind of odd cases that you may run into. All right, so good luck on the assignments, and please email with any questions you might have.